Hello, Zishan. I'm audible.
Yes, you are audible.
Okay, so I'm assuming you're the student, right?
Yes,
All right.
much.
All right. So you're taking AS level physics at the moment, right?
Yes, I'm taking ES level physics.
All right. And if I'm not wrong, you must have got your O levels results by now.
Yes, I got my O level results back.
And how is it?
It's good. I got an A star.
11A star. Wow, that's wonderful. That's good to know. All right. So just to let you know, my name is Mohammed and I teach physics, AS and A2 as well. So for now, today what I will do, I will go over briefly, all right, about few topic, maybe work energy and power, and maybe we can discuss that. And also a question from past paper, all right? Does it sounds good to you?
Yes, it sounds good.
Okay, so let me share my screen. Just give me a moment because I use OneNote and writing pad. So let me share my screen. A white screen will appear in front of you. Can you see the screen now?
Oh yeah,
All right. So Zishan, your name is Zishan, right? Abdul Hadi Zishan.
yeah,
Okay.
yeah. My name is Ishan.
Okay. All right, Zishan. So I've been teaching physics to many students. Sometimes they have difficulties understanding the concepts, and sometimes they have difficulties understanding the question. Generally, when they understand the concept, so sometimes they do not know how to phrase the answer, how to solve the numerical question, right? In the past paper. So, uh, are you looking for a general help in physics in AS, right? You appearing in uh 2027,
Y-
May, June?
Yes, I'm appearing in 2027.
Okay. All right. So if we talk about work, energy, and power, what is work? Work is basically nothing, it's just energy transferred when a force causes movement. I have written somewhere here a small phrase, right? So it's energy transferred when a force causes movement. For example, if I ask you to climb two stairs, so you will get up and you will apply a force and you will travel certain distance. So you are doing a work, right? So it's basically force time distance. Distance is the distance traveled when there is a force applied to an object, right? And if we talk
Yes.
about energy, what is energy? Energy is the capacity to do work, is the ability to do work. Sometimes we
Mm,
have kinetic energy, right? There's a motion, so it's kinetic energy half mv square, and sometimes there's a gain in height, so we have potential energy, gravitational potential energy, which is mgh, right? And sometimes energy is lost due to friction, due to sound, due to heat, right? You are aware of this, right?
yes, I'm
And then,
aware.
yeah. And then the next subtopic in this general uh, discussion is basically conservation of energy. What happens? Energy cannot be destroyed or created, it can only be transferred or transformed, right? That means it can change its form. It can convert from kinetic energy to potential energy, or from potential energy to kinetic energy, right? Let me just give you a small example, right? When there's a, for example, there's a slope. Let me make a slope over here, right? There's a slope and there's a ground, right? This is the ground. If the ball is here, height of the ball is, for example, 5 meters, and it goes down there, right? And the height is 0 meter. So what happens? Potential energy, there's a potential energy because there's a height, right? There's a certain mass, mgh. And what happens? Potential energy converts into kinetic energy down the slope. And over here, the whole potential energy is converted into kinetic energy. You make sense?
Yes, it makes sense.
Right. The next thing in the topic is power. What is power? Power is the rate at which work done or energy is transferred from point A to point B. So if I say what is the power of the ball at point B? If this is B, this is point A. So we can definitely calculate kinetic energy and we divide it by time. So we need to know the time, how much time it took from ball to go from point A to point B, and what is the kinetic energy of the ball at point B, right? Which is half mv square. So we need to know the mass of the ball, the velocity of the ball, right? And the time taken so we can find the power, right? Make
Right.
sense? Make sense?
Yes, miss, makes sense.
All right. If I'm going fast, if I'm going slow, you can definitely talk to me. All right. No issues. It's just that we are short on time, so I'm conducting the demonstration, the introduction session. All right.
Okay.
All right. So what happens in AS? You don't need to worry about A2 and AS level. AS level, we have paper one, MCQs. We have paper two, this is structured questions, right? And then we have paper three, practical skills, right? If I'm not wrong, you will be taking GCE, AS level, right?
Yeah, GCA.
Yeah. All right. So it's like general AS level, right? And where's your school, if you don't mind?
It's in Riyadh.
It's in
The school
Riyadh.
name is Spicy.
Okay. Okay. So you fall in Saudi Arabia. All right. No issues.
Yes.
So these are the basics of the work energy power, right? The critical part is sometimes we can get questions on conservation of energy. We have to apply this concept, right? So I will discuss
Right.
this topic in detail later on, right? But right now, what I want you to look at is this past paper question. Okay. So if you have done scalar and vector in O levels, I'm sure you must have done scalar and vector. What's the difference between scalar and vector, if you can define me?
Scalar has only magnitude, while vector has magnitude and direction.
Exactly. And what's the difference between distance and displacement?
Difference between distance and displacement.
Yeah.
Distance is the distance from one point to another, and
Hmm.
displacement is the shortest distance from one
Exactly.
point to another.
Exactly. So you can write displacement is the shortest distance from a fixed point with a certain direction, right? The
Yes.
shortest distance. So you can write the first question over here, 2.1a, A1, that you can write what you just said, right? Use the definition to explain how it is possible for a car to travel a certain distance and yet have zero displacement. That means the car is starting from its starting point, right? Returns to its starting point. Make sense? That's
Yes,
why
makes sense.
that's why it has zero displacement. For example, if the car is starting from here, going there, and it's coming back to A, so that means displacement is zero, right? But but
Yes.
but in other words, the car have traveled this much distance, right? Make sense? But yet the car have zero displacement if the car returns to its starting point. So that's what we're going to say. So you get 3 marks on that, right?
Yeah, right.
Okay. Can you read out part B? Is it clear to you? I mean, any questions?
Yes, it's clear.
Okay. Can you have a look at part B? The diagram, everything, the details. Have a look at it.
Okay. Diagrams, details. Okay, the car starts from rest and
Right.
travels up along a straight road inclined to an angle of 5.0 to a horizontal, as illustrated in figure 2.1.
Right. So what is happening in the figure point 2.1? The car is going uphill. The angle is 5 degrees. The mass of the car is 800 kilograms. And the distance the car is traveling is 450 meters. It's starting from rest. That means U is zero, initial velocity, right? And they are
Yes,
saying it is has a constant velocity, constant rate of 28 meter per second. So our V is 28 meter per second, which is the final velocity, right? At the top of the slope.
yes, right.
Over here V, over here is U. You are aware of initial velocities and final velocities, right?
Yes.
Okay. I will cover that topic later on. It's just like a combination of two topics. So we will just find the v square equals to u square plus 2as, right? It's always good to write the formula first and then solve. So we put the values 28 square equals to u is 0 plus 2a. And what is s? S is the distance the car travels, which is 450 meters, right? Do you
Yes,
have your
450.
Yeah, 450 meters is given in the question. Do you have your calculator by any chance?
Yes, I do have a calculator.
So can you calculate this value for A? I'm getting acceleration as 0.871. Are you getting the same?
So I'll have to do use these 20.
Yeah, so basically we put 28 in place of v because that's the speed at the top of the slope, that is final velocity. Initial velocity is 0 because car is at rest, right? And then s, the distance the car is traveling is 450 meters. So we put 450 in place of s in the formula.
Okay.
And it's always important to write the units with the answer.
I got 28 square divided by 900, 0.871
Yeah,
meter per second.
that's good. So you're getting the same answer. That's good. Now, in the next part, they're saying the time taken to travel the length of the slope. So we can
I'm
use,
taking
yeah.
the length.
So
Okay.
there's one formula which uses time, final velocity, acceleration, and initial velocity, which is v equals to u plus at. Are you familiar with this formula?
Yes, I'm familiar with this
So
formula.
we just use that 28 0. We put acceleration as 0.871 and t. So we can find the time t. We do 28 divided by 0.871. So we get 32.1 seconds, right?
Right.
You got the same answer?
Yes, I got the same answer.
Any questions, any confusion so far? You can share your thoughts.
Uh, no confusion.
No confusion. All right, that's good because we're on the same page then. That's good. Let me move forward. So we see the gain in kinetic energy. Kinetic energy is basically half mv square.
Yes.
We know the mass of the
So
car. What's the mass of the car?
800.
Is
800.
800 kilograms. That's right. So we put 800 in place of mass and we place velocity 28.
0.87. Uh,
28 velocity,
no,
right?
right.
28 square times 800 divided by 2. So we get 313,600 joules. So that's the gain in kinetic energy, right?
Right.
Now they're asking the gain in potential energy, which is potential energy is always the formula mgh. We need to know the height.
Yes.
We need to, if at,
So we'll use 1 over 2 mv square equals mgh.
yeah, we can do that, or we can find the height through using uh the right angle triangle formula. We have
Yes.
we have 5
Is the
degrees.
height 40 meters?
So it's 450. Angle is 5. So what would be the height?
Is
It's
the
only
height 40?
let me check. Let me check. It's opposite over hypotenuse. So sine 5 times 450. Yes, around 39.2.
Okay.
So it's 39.2. So mass is 800, gravity is 9.81, height is sine 450 sine 5, right? So now we can calculate that. 800 times 9.81 times 450 sine 5. So the gain in potential energy is basically 307,799.22 joules. All good?
Yeah.
Any
All good.
confusion on this one?
No.
So that is conservation of energy. That what you said. Kinetic energy is equals to potential energy. So you can find the height, right?
Hmm.
Right? Or
Right.
you can find the height using 450 sine 5. There's the right angle triangle formula, right?
Right.
You can sketch and you can find that. All right?
All right.
Okay. Now let's look at the next part. They're saying use your answers to determine the useful output power of the car.
Hmm.
What that
Using
would
our
be.
useful power. So power equals distance time.
Work done. Yeah. Or we can what we can do. The energy over
Yeah. Time.
time. Yeah. Just a minute. Let me stop sharing my screen for a bit. I just got something. Just wait a minute. All right. So we can calculate the power by that, right?
Yes.
Let me share the screen again. Just a minute. All right. Now, the last one. Suggest one reason why the actual power output of the car engine is greater than calculated in two. The actual power output is greater. So we can say easily that there must be some energy wasted against friction, right?
Right.
The surface of the slope might be rough. So there might be some energy wasted in the friction so that what we calculated is higher than the actual output, right?
Yeah, because also the energy lost to the surroundings.
Yeah, some energy is lost, right? Any questions, any thoughts so far?
No questions.
Okay. Before we end today's introduction session, what I want to do, I want to discuss one more pendulum aspect of it. For example, there's a pendulum is hanging, right? And that's the reference point. It moves there. That's the maximum height it reaches, and moves there on the left hand side. That's the maximum height it reaches. So that's the height, and that's the height. They are same heights, right? So I'm marking them H. So it moves there, and it comes back, right? The oscillation, right?
All right.
So if you can see the diagram, Zishan, can you tell me where the kinetic energy of the pendulum would be maximum? Which point? Let me label the points. This is A, this is B, this is C.
At B
At B, and why?
because it has the most energy stored right now.
Most energy stored, or you can say because highest velocity
Yes.
and zero height. So there is no potential energy, right? So where would be the greatest or highest potential energy in the diagram?
Um, at C.
At C and also A, right? Because they have same heights. So at points A
Yeah.
and C. So if I ask you to write if it's a 3 mark question and I ask you, Zishan, please write the law by using the law of conservation of energy, explain the oscillation of the pendulum. So you will say the pendulum starts at its reference point at a maximum velocity, goes up to point C, and the kinetic energy converts into potential energy, right? and then it returns from C to B. The potential energy converts back to kinetic energy, and then B to A, again, kinetic energy converts into potential energy. It raises a height h, right? Make sense?
Right. Yes.
Any confusion?
No confusion.
All right, Zishan. So I think that was the introduction session for today. It was a brief one. We were short on time. So
Yeah.
my feedback is that you have good grades, you have good backing from O levels, you have 11 A stars. So from AS, if you continue with us, what my plan would be? My plan would be to cover the syllabus with you, do the past papers questions with you, prepare you well for the exam.
Hmm.
We can do topical questions, we can do, and then yearly questions as well. So that will prepare you for the exam. At
Okay.
first, at first we will at first we will be focusing on topics. All right.
Okay.
You think like a good game plan for this one for physics?
Yes, it's a good film. Yeah.
Any feedback from your side?
No feedback.
No feedback?
Yeah.
You are all good. My writing was fine. My pace was right. The screen was clear.
Yeah.
The sound was good.
Yeah.
No issues with online teaching. All right.
All right.
All right. So you can discuss with Iraj. All right. And let me know that if you
Okay.
want to continue with me then.
All right.
All right.
Allah Hafiz.
Allah Hafiz. Thank you, Zishan. Bye.